Well, hello world. Get comfortable. Grab a coffee and a cookie or something. I'm going to spend the next probably hour or so going over MJT services and what it is and what this thing is I've created. This is going to take a while. I have a full mug of coffee. We're just going to kind of do this in one take, and hopefully it'll not be too horrible. 100% put this on double speed or something like this. Don't listen to me drone on. Um, but I'm going to start with an overview of what this thing is, and then we'll go into the code and we'll get into the nitty gritty details. But to begin with, we'll just start with an overview. So, what are MJT services, or what is MJT services? MJT Services is a GitHub organization that I created that essentially just packages up a set of GitHub repositories. So let me just show you the GitHub repo here. There we go. There's the repo. If we go to repositories, you can see all the repositories, right? So there's lots of repositories here. And so what this video is I'm going to attempt to paint kind of a big picture of what this thing is, and then why others might find it interesting, at least take a peek at it, and also just to kind of document the progress of where I am currently in this, what I'm doing. So here we go. So MJT Services started this year. I don't know exactly when the official date would be, but let's just say January 1st, 2025. Been working on this for several months now. And what it is essentially I don't know, repackaging, crystallization, a playground, perhaps, for all of my thoughts and ideas on essentially digital service infrastructures and how they want to work. In particular, how they want to work in the age of AI, right? And things like text generation and image generation and TTS and ASR and vector databases and just data in general and how that wants to work, right? Just a myriad of services that I want for myself as I kind of play and explore um, with things, right? It started out with as a home assistant project. So essentially, I just wanted to create a little home assistant to help me do things around the house, and AI driven and all that. And then as I started building that, I realized I needed to build the back end services to make that thing work. And so I'm still working on the home assistant project, but the kind of the digital infrastructure underneath it kind of came to dominate my time, and I just found it maybe more interesting to work on to some degree, right? Because I'm more of a back end guy than a front end guy, really. And so that's kind of the evolution of it. Now, to start off with, like the big learning I had in over the last maybe couple of years of kind of working with AI stuff and building like agent infrastructures and stuff like that is that um, it needs to be fast, and you're not going to understand fully how it's all going to work. And by that I mean I'm in a present moment of time, and maybe that's just going to be forever, the rest of time, um, where things are happening at such a rapid pace. New areas or kind of open up new vistas. New things are happening, right? At such a rapid pace that one can't really truly fully anticipate what tomorrow's going to bring or what services you might want tomorrow. And so you want to build an infrastructure that is very dynamic, right? And that is very, where all the services are very, independent, very composable. They kind of live and die their own lives, right? And so that's kind of one of the major learnings, right? And so that's why this is all based upon a message queue. Can I highlight this? Yeah, that'll work. It's all based on a message queue. Now I'm using something called NATS. NATS is just an open source message queue framework, like RabbitMQ or what have you. It's so far it's worked pretty well for me. I've been happy with it, so I can recommend it. But I don't have, what would I say? It's kind of like just the best tool for the job in this moment. I don't want to say that NATS is going to be the end all be all for all the rest of the time or anything. But the message queue, I think, might be, right? So I think that's the key thing, right? Is that the concept of a message queue is really kind of a fundamental, computer science concept. And I really think that's the way that kind of back-end digital infrastructures really want to be built, right? REST is nice, right? And having a direct connection, like TCP connection between services, is one way of going, right? But you have this horrible, horrible problem of discovery, right? Of service discovery. And you have this horrible, horrible problem of kind of having to reinvent the wheel all the time on API interfaces and how they're going to talk and what what the patterns are for talking between the services. And so at the end of the day, you can build it like all on REST, right? And REST is, obviously in my lifetime kind of come to dominate. It's kind of like a lowest common denominator, right? It's sort of like, everything can talk REST at this point. And that's the web, right? So there's nothing like it's not going away, right? The service infrastructure I built also depends upon REST services and so forth. But the key thing is that all the if you want to call them microservices or whatever you want to call them, all the smaller services really, I don't think, want to expose themselves via REST unless they have to, right? So there's a just sort of a natural tendency, I think, to all services to gravitate towards something that looks like a message queue. So this is, I think, who knows, 10, 20, 100 years from now, things will change. But for right now, in this moment, it feels to me like the message queue is the kind of the dominant infrastructure pattern, if you want to call it that, right? That one wants to use. If you have a variety of small services that all need to kind of talk to each other, and you want to do it kind of as simply as you can. How scalable it is, I think it's in theory just about as scalable as any other solution. The message queue is kind of a well-established kind of pattern at this point. And so far, and at least, for like my home project, right? I don't have tens of thousands of users or anything like that. It seems to be performing very well, right? So I don't have any latency issues or anything like that. But that'll be if one takes this idea, right, and just kind of runs with it, that might be you might discover that, hey, having to scale the message queue becomes the problem, right? And there's always going to be something that becomes the problem. when you're trying to scale and so forth. And that might be the case here with the message queue. Or, you can do distributed message queues, and you do sharding, you do all sorts of fun stuff, right? So there's ways of solving these problems when it comes to scaling. But maybe scaling isn't the solution, right? Maybe you scale in different ways. So anyway, enough about that. So you've been looking at this diagram here for a bit, and let me just kind of break it down a little bit as far as what this all means. So the message queue is, like I said, the central sort of thing, right? That's what everything is connected towards. I have here on the side Cloudflare Tunnel. So I'm using Cloudflare's Tunnel service, I guess you would call it, for exposing internal services to the web, right? So I'm not going to go into, I mean, maybe once we get into the code, I'll go into more detail on that. But hopefully, it's the Cloudflare tunnel infrastructure is really amazing, to be perfectly frank. And I don't understand how they make money off of it, to be perfect. I don't understand. That's probably my one question with Cloudflare tunnels is like, how does Cloudflare make money off of it? Because it seems to be this free service that they just provide out of the goodness of their hearts. And so I'm taking advantage of it. Who knows how long that's going to last, right? But I guess take advantage. Cloudflare isn't going away anytime real soon, but we'll see. So that's a service that I kind of currently rely on, depend on. I'd have to create myself. I'm glad I don't have to create myself, right? It's just kind of a security thing, right? So that's one thing to know, is that it's all kind of exposed through Cloudflare tunnels if you want to go out onto the web. But let's talk about these individual services for a moment. So let's just start here with data. So the data service is essentially an object database design that I've created. It's kind of simplistic. It serves my needs for the moment, and I think it's kind of okay. Like it's not going to scale to trillions of records or something like that. And it is a very simple object database. We'll get into the code of it when I get there. But we'll see how long it lasts. So this is kind of an innovation of mine, right? I'm not using Postgres. I'm not using other Mongo or something like that, right? So this would be it's a very simple data framework, right, for persisting data and searching and doing all that sort of stuff. So we'll get into that when we get into it, but just know that it's my own little creation. So daemon, or daemon, however you want to pronounce it, I'm going to pronounce it daemon. I'm going to try to. I flip back and forth quite a bit. So this is an old, is it Greek word or Latin? I can't remember. I think it's Greek. That I guess the early Christians sort of demonized. It used to be a good thing, right? Your inner demon. So I'm trying to bring it back. Or I'm trying to bring the word back. And obviously this is a play on Unix demons and so forth, and they were doing the exact same thing. Yeah, that's why we have Unix demons, right? Because they found it amusing to do so as well. So I'm just bringing that word forward as well. Essentially that's my word for like an agent, right? So we'll see if that agent or assistant wins out, what wording we end up using, right? It's still early days on this sort of thing. So this is my little play at that. I just sort of like it's DAIMON. I like the AI in the middle of it. That's sort of how I came to that. But anyway, so this is my little agent service, right? For doing agent-like sort of stuff, right? And we'll get into the code of that later. Text generation service. So this is obviously very important now. This is effectively kind of what people think of when they talk about AI. They really are talking mostly these days about text generation. Because because that's the thinky sort of bet of AI, right? And so I mean that's just the way it is, right? We view something as intelligent if it can speak, right? Um, and I don't know. There's all sorts of philosophical stuff around that. But anyway, so there's a text generation service, right? So what this is it's really mostly a router that goes back, can routes to like like an OLAMA sort of thing. If I want to do local inference, they can route to a like I use Open Router for API kind of services because then I can kind of forward that to a multitude of other services, and I just have kind of access to all of the nice open source models as they come online. Um, so whatever. It's just everyone's using the OpenAI uh, with small variations, I should say, the OpenAI API, I don't know, scheme, framework, whatever you want to call that, um, protocol. So it doesn't really matter at the end of the day. But anyway, so it's just mostly a router, right? But it does mean that I have a concept of an internal concept for how I want to package up text generation and so forth. So I have my own formats, my own protocol for doing that internally that everything else consumes, right? So it also kind of translates back and forth, right? So it's kind of a translator as well. ImageGen is very much the same sort of thing. And actually, this one, I think I'm just have Uba Booga back in for it because I'm kind of an old guy, and Uba Booga is where I kind of started out, and it has a REST API, and it's kind of good enough. Everybody's kind of using Comfy UI these days for if you're going to do internal generation. I don't really have any third-party API stuff for that because the image generation models are kind of small enough that one can kind of run them on a GPU internally pretty successfully. So that's what I tend to do. But it might change in the future. Another API service, just like with text generation, I can route back and forth, so it's not a big deal. ASR, automated speech recognition, I believe is what that stands for. So that's just the decoding what the uh, from audio to text, right? And so that's needed mostly for like this home automation thing that I was building. I'm surprised I don't have a TTS service built out yet, but I just don't because I just haven't gotten that far. I've done that before, so I know the possibilities of that, like voice cloning and all that sort of stuff. So I'm sure that'll come online in the future. But for right now, it's just ASR. CLI, so I have a little CLI, maybe we don't call this a service, it basically connects to everything, right? So this is, if I want to do like command line text generation or something like that, I have a little CLI framework for doing that, right? That connects to the message queue and then depends on the text generation. So these little arrows here, not really sure what they mean in some sense, right? So it's basically the CLI depends upon the message queue and depends upon text generation. It depends upon ASR because I believe I have a mechanism for like catting audio files and getting text back and that sort of thing. So I haven't connected to image generation yet, so I should probably do that at some point. But anyway, so it's just like if I want to do it at the command line, this is how I'm going to do it. Vast AI is kind of an interesting service. So what Vast AI is it's a you can think of it as kind of like a GPU rental marketplace. Kind of cool. It's similar to like you have AWS or all the different cloud infrastructures, right? That will rent you a machine that has a GPU attached to it and so forth, right? Well, Fast AI kind of doesn't rent you the entire machine. It's all based on Docker and Docker images, which is at the end of the day really what most people want, I think. Um, and the interesting thing though is it's just a full-on marketplace where anybody can essentially install their client and expose their and essentially sell their GPUs on the open market, right? Which includes corporate people and data centers, and just kind of just anybody who just happens to have a 5090 floating around, right? It wants to make some money, right? Um, and so I think it's for the cheapest I've seen, like currently, marketplace for doing, like, if you want to rent a GPU or something like that. So that's the one I'm currently using. And I've used them for, I don't know, maybe a year or two now, and had good success with it. So I have a full. So this is essentially a management service for bringing up instances, tearing them down, monitoring them, that sort of thing. Um, that's really what that is, because in the uh, one of the things I like to do occasionally is spin up a something in VAS to do, because I want like an A100 or maybe a few A100s or something like that, right? Or an H100 or something. And I don't want to spend $250,000. But maybe I'll rent it for, a few bucks an hour, right? That sort of thing. So I think that's just an economics thing, right? And so I think the SCI is definitely the way to do that if you're interested in that sort of thing. Tunnel. Whoops. Did not mean to do that. Whoopsie. Oh well. Put it back. Tunnel is actually, let me Control Z that. Thinking about it. There we go. Hopefully Control Z. Tunnel is essentially a service for connecting. Um, I need to connect the service that I expose via Vast AI to my internal message queue framework and so forth. So that's really what Tunnel is. We'll get into more nitty gritty of that later, but that's essentially what that is. Like, it says SSH tunnel sort of stuff. I maybe should have called it SSH tunnel. But it's a way to tunnel traffic, right, securely from these services running out there, on the web somewhere, right? And so it's just a way for me to communicate back and forth to these services that I'm spinning up in, like, Iceland or Europe or wherever, right? Let's see, web client. So that's essentially like scraping, like, or I called it web client because it's essentially just, it's a wrapper around, oh, not Puppeteer, the other one, Playwright. Um, and so you can control a web client, right? So right now, really, the only kind of interesting thing I'm doing with it is scraping data from websites, but you know, in the future, it might get more complex, right? Especially with agents or demons or daemons, uh, and how they might want to reach out and control things on the web, right? So we'll see. I'm certain there'll be like an MCP client and all that sort of stuff forthcoming. So we're living in a fun world. Um, and then just have these little ellipses here because the future, right? There's going to be other services. The idea here is this is expandable, right? And just as I want more things in my life, in my, I call this, maybe sometimes like my digital home or my digital infrastructure, home digital infrastructure, that sort of thing. As I need these things, I just want to build a service for it and then just have access to it, right? Because this is like I don't know, kind of like a personal workshop. I did a video yesterday, kind of going over um, like how to hook up Brave via bring your own model to API. We'll call this API now because I forgot that one. That's one I just recently created. Because I have a service now that exposes my services via the OpenAI API that I just talked about. That everybody kind of talks through, right? So Brave talks through that as well, but I had to expose myself via that, so I had to mimic Open API, right, as everyone else is, to expose all my stuff, right? So it gets real fun. Abstractions built on those abstractions. It's a tower of abstractions to some point. um, which is maybe not a good thing, but we'll find out. The So where was I going with that? Anyway, so future things, right? So I'm going to have collections of services, and I just kind of want to. I've discovered that over the years, I have maybe hundreds at this point of just kind of projects I've done for myself as I kind of explore an idea or do something or want something. And I've gotten into the habit of, I don't want to, it's kind of like dry, right? Don't repeat yourself. I kind of like want to build something once and then it's like, well, this is how I want to do it. And I'm going to do it this way going forward. And here's my library for doing this and so forth. Well, I have a library set that I call MJT Engine, which is, it's, you can kind of think of like a game engine sort of thing. And that sort of concept where it's essentially just a rough collection of useful stuff for doing something. So in the game engine world, it's for doing game sort of stuff like rendering and handling input and that sort of thing is usually what a game engine kind of gives you, like a Unity or something, right? Well, my engine is similar to that. I actually have I was kind of starting down the path of trying to do game development and that sort of thing, and that's kind of where this idea kind of started to some degree to have this set of libraries. Um, and so there is actually rendering and 3D rendering and all that sort of stuff that this thing does, but it's also like a math library, and it's also like a library for doing like NLP stuff now, and just strings and objects and just anything, right? That is kind of a general utility sort of thing. So anyway, so I have that NJT engine as like a library of code, right? It's all TypeScript. I've decided that TypeScript is the language I really like. I decided that about, I don't know, about 4 or 5 years ago or something like that. I'm an old Java developer, if you don't know much about me. But I decided that TypeScript was better, right? It's just more elegant sort of language in lots of ways. And so I kind of jump ship to TypeScript once I jumped the corporate world, right? Stopped having to do that. Uh, so anyway, NJT engine libraries. This is the services kind of aspect of that, right? Where it's like if I have like text generation or something like that, like I don't want to have to keep recreating a text generation API that I want to talk to, right? I don't want to have to kind of recreate that over and over and over again. But I do want like a level of abstraction, right? So text generation is probably a really good example of this, right? Where um, I see you started out doing what was it, automatic 1111, right? And had, oh hey, this is kind of cool, and oh hey, this has an API, I can do that, right? And then it's like, oh hey, there's the OpenAI API, right? And then I don't have to do Uba Booga, or is it Uba Booga or Automatic 11? Automatic 1111, I think is the section right, but I apologize if I got that wrong. Um, but anyway, so I don't have to do their weird proprietary thing. I do the OpenAI, right? And who knows, maybe at some point OpenAI will cease to be, or we won't be so happy with that, right? And there'll be another API we want to speak or something like that, or a different way of doing text generation. Who knows? Maybe it'll be like diffusion models for text generation or something like that. Crazy stuff, right? We don't even know about, right? But I'm still going to want like my service infrastructure. I don't want to have to relearn the wheel and how do I phrase this? Like I want to have some semblance of stability, right? Or some way that I know that I want to do things, right? Like there's things that I know I need to want to do, right? Like I want to stop the text generation, right? I want to abort it. I don't want to have to relearn how to abort things all over the place, right? I'm going to stream the data, right? So how do I stream the data to like a user interface or something like that? Like maybe I'll have components or something like that to do these sorts of things, right? So I don't want to have to keep recreating the wheel over and over again every time I want to do something. Like I have some project in mind, and that's just sort of a thing that I do, right? I just create little projects and I play and discover stuff. That's just kind of where I am in life. uh, and so that's what's important to me, right? Is to kind of create a thing, explore the idea, the concept, like it's obviously useful to me in some way. Like text generation is very useful, right? It's very interesting kind of concept. Same with image generation. Same with all these services, right? They're all kind of interesting to me in some way. And there's things where I need like web client, right? Like I don't want to have to recreate, oh, how do I do the Docker or the Puppeteer thing, or Playwright, or all that sort of stuff. No, I just want a clean API that I've created that I know how to talk to, that is consistent. And then at some point in the future, and I do want level of abstraction, because um, projects sometimes go in bad directions, right? And so I want to be kind of able to pivot, right? Maybe Playwright isn't the thing. Maybe I want to do Puppeteer. Maybe I want to do whatever the next thing is, right? Um, but I just want to have my, there's some fundamental ideas, right? I'm going to go to a URL. I'm going to want to, convert the page to Markdown. I'm going to want to do whatever, right? As a set of services, at kind of a high level. What's underneath that, I don't really care, right? I want to abstract that away. So abstractions are kind of dangerous things, but they're also very powerful. So I want to use them where it's appropriate. Anyway, so that was a lot of talking and gobbledygook. Let's get into the code a little bit, maybe. Let's see how that's going to work. How are we doing on time? Where do I see that on OBS? I thought you could see that. I'm sure I could see that. Oh, here it is. 31 minutes. All right. So that's not too bad. Not too bad. So, maybe take a little stretch break, pause me. Oh, I know that I just ran out of coffee. That's a horrible thing. I might have to take a break myself. But we'll push on for a little bit. We have some coffee left. All right. So let's go into VS Code and turn that off. All right. Can you see that? It looks like you can see that. Does it look good? I hope it looks good. All right. So let's clear this out. Let's try to make this as simple as possible. I guess I don't need this for right now. All right. So I think this is about as simple as I can make it. Maybe I can make the screen a little bit bigger. Is that going to do good things? Yeah, it looked like it did good things. All right, good. All right. So let's talk code here for a minute. Where do we want to begin? Let's begin in the message queue service. So, like I said, I'm using Nats, which is a, let's see, do I, Nats, message queue, let's search for that. Let's go to Nats. Let's go back to the web. Oh, browser. There we go. All right, so there's Nats. Documentation. Yeah. All right. So it's a pretty good project. I can recommend this. It seems like I like their monetization model. So it's an open source framework or tool, or what do you want to call it. But they and like anything kind of like this, we're trying to figure out how to monetize it, right? So it's sustainable, and they're creating good high quality documentation, and they're staying on top of bugs, and all that sort of stuff, right? So I'm very happy for them to make money. So hopefully I could chill for them a little bit here. But the reason I'm using them is obviously because they're open source, right? And I'm not going to tie myself to anything that is proprietary at this point in time, right? Unless I just have to, because there's no open source solution that's good enough, right? So what do I want to say about this? So it's a variety of languages. It has a variety, you can use Go, you can use, I think is it written in Go? It's written in Go or Rust, I can't remember. Actually, we can probably find out here. It is written in, sometimes it says here. If I can figure it out. Can I figure it out in Go? Bang Go. All right. So it looks like it's written in Go. which is fine. But it has clients written in like a multitude of languages. .NET, Java, Go, Rust, Ruby even, holy mackerel, uh, Elixir, and JavaScript, right, or TypeScript. Uh, so that's the one I'm using, and so I'm quite happy with that. It has a Docker container for the back end, and so that's what I'm using as well. Let me explain how I'm doing that actually, because that's kind of interesting. So what I'm doing as far as like Docker containers and so forth, because I don't trust, is I do this, right? So I just take their Docker container and then I create my own image from that, right? And so I have my own Docker file, right? And then obviously Docker Hub is kind enough to give you free, uh, kind of unlimited um, space as long as it's open source or as long as as long as you make it public, right? That's the deal. Currently, this is all just residing on my laptop anyway, so it doesn't really matter. But this is my way of saying, well, if Nats does something I don't quite like or something like that, at least I have my images kind of here local. It's not a perfect solution, but it's what I'm going with, right? Yeah. So that's why I'm doing that. Here's my Nats config. Hopefully I'm not going to expose any secrets. No, got to be careful of that. So let's be careful of that and cognizant. So we're not going to click on the .env file, which is where all of my tokens and that sort of thing. So it's all token based. NAS has a way of doing non-token security based on like this public-private key mechanism that I like. They semi-support JWT, but not really, or just kind of barely, or I don't know how you want to describe it. I tried to use that route, and it just it got very frustrating. So I just went ahead and it just fell back to using token based, and it works good enough. So that's fine. Um, so for all of my Docker images, I have this set of scripts. Two scripts in particular are very important to me. Build. So if I'm building a Docker image, I have the set of scripts, just the shell script that does the thing, right? So it builds the Docker images. So I'm very consistent in that. So in all of these projects, they all will have, if there's a Docker container involved, there'll be a scripts directory with a build shell script that will build the thing, right? And then this will do whatever it needs to do as far as like getting information from the .env file. So the .env file is where I store a lot of configuration information in addition to like security stuff and everything. Maybe that's not the greatest idea in the world, but that's what I'm doing. And then the other one that I have everywhere is run, which is essentially how to run the container. I'm not using Docker Compose or you know, uh, Kubernetes or anything like that. I'm using just straight out shell scripts. Uh, that's just for me. That is, I like to keep that very simple. Um, uh, and I want to be in kind of control. Like one of the things I hate about Docker Compose is that it assumes you're running on a server all the time, right? So it keeps wanting to restart services and stuff like that, right? And so it's just sort of like magic, and I don't like magic. Kubernetes is better and it's less magical, but it's just very complex and heavy, and I don't want that either. So I typically just go with shell scripts. Maybe at some point we'll have to bite the bullet and do Kubernetes or something like that, but I'm going to avoid that for as long as I possibly can. So just shell scripts. I'm doing, like I said, Cloudflare tunnel to expose everything. I'm using the Docker networking stuff to have the services communicate with one another. So in case you didn't know, that's just a thing you can do. So you create your own little private network, and then you essentially, it's kind of annoying. I wish it was idempotent with this, but you have to do this little thing, right, to make sure the network exists. I wish it would either just automatically create the network if it's named, or be okay with create just, you know, not erroring out. So anyway, I had to do this little shell script chunk to say, hey, create if it exists. If it doesn't, fails, no problem. Um, so like I said, I'm using Cloudflare D for Cloudflare tunnel stuff. Again, it's connected all through the tunnel infrastructure. I'm just using the straight out Cloudflare D um, image that they provide. I haven't kind of wrapped it in my own little Docker image or anything like that. Um, we'll I think that's good enough, right? It's all sort of uh, who you trust and what you want to do here, but I'm just trusting them on this one. Um, so we're using that, and so it just starts Cloudflare daemon, and then obviously it just does the Docker run stuff where we use the in files. We're using the in file trick with the Docker thing to get the .env stuff inside of the environment of the Docker container, and then we're obviously we have the snaps config, which is just a bit of magic. Obviously, this is very kind of lots of commented out stuff, and it's kind of sloppy, I guess I would call it, as I've been playing around here. But yeah, you don't really need a lot, right? It's probably the biggest thing is I've increased the max payload to 8 megs. Uh, I think I needed that for like images and stuff like that as I push them across the message queue, which is an important thing to talk about. That I'm doing binary stuff. Do I want to talk about that now? How do I want to just approach that? So yeah, let's talk about it now. Really, that's kind of an MJT engine thing for how to do that, but we'll just kind of go over it. Message queue service, message queue common. Actually, that is an MJT engine. Yeah, all right. Let's head on over to MJT engine. Let me bring up that over here, and then we'll go here, outline, close the chat, I guess. Sure. Close the chat. Bring VS Code up here. Can I do this? MJT engine. All right, there we go. Now you're looking at MJT engine. Let's make this bigger and nicer for you. All right, let's get on to, oh, this is MJT dev engine. This is the wrong engine. So I had a false start for about a few years. TypeScript, or JavaScript rather, has a horrible dependency mechanism thing. And it's real annoying how it works with dependencies. And so it turns out you don't really want to use the package stuff like monorepo stuff. Monorepos are just horrible things in my estimation. I've never been happy when someone gets the bright idea to do a monorepo. It just sort of destroys the whole composability, the whole small services, small tools, simplicity aspects of code. And so I'm very much against monorepos at this point in my life, I think. But I tried with that just because of the dependency hell that one goes into. But anyway, so I found a better solution, which is to use the GitHub. This is why I'm using the Git organization mechanism, right? That allows me to create a kind of pseudo, how do I want to phrase this? Like an NPM, you can have, is it called an organization? What's it called? A little at, whatever. So I have an at MJT. Let's look at string here to show you that. So I have at Matt MJT-engine, right? So I've, that's an official NPM repo sort of thing. But I don't use NPM repo for publishing, right? I just decided I didn't want to have to do that to play their games on how to do that. And so it turns out you just use GitHub as a repository mechanism. So that's what I use. It's maybe at some point I'll go ahead and publish stuff to npm, but for right now GitHub seems to be good enough, and I kind of like it. It seems simpler to me, right? To just store all the assets and stuff like that is in GitHub itself. Maybe I'm abusing GitHub a little bit, but it seems to work okay. So where was I going? Message. All right, so there's a message project here in MJT Engine. I apologize, I haven't even gone over, I went over a little bit what MJT Engine is, so I guess you're not totally lost. And so anyway, so this is MJT Engine. You can see that it has a selection. You can see my mouse, what I'm doing here. Yeah, you can see I'm pointing. It has a plethora of little small modules that do different things, right? Like I said, deal with images, deals with color, right? Color is a very important aspect if you're doing game development, right? Noise and randomness and math, and BABS is actually this is probably the largest module. What this is it's a kind of a wrapper around Babylon.js, Microsoft's WebGL rendering framework, right? So I keep going back and forth between Babylon.js and 3JS. Babylon.js is more complete. It's sort of it's a huge monster, but it's just a kind of a better, how do I phrase this? It just has more stuff, right? It's more complete, and so it's a little bit easier to work with in some ways, but it's a little bit opinionated, and some of its opinions are wrong. So that's a problem. 3JS is less opinionated, and it's a cleaner, more refined, more elegant kind of project, but it's not as complete. It doesn't have all the things that one might want. So there's a trade-off there, right? And so I'm using Babylon.js for currently. Anyway, so that's what that is, Babs is. So that was a tangent. So let's look at message. So message is essentially messages in the context of WebSockets and MQ systems. So that's what this is. And so WebSocket is how we connect, how would I phrase it? So it's sort of a long-term, long-running connection point between the browser and some sort of back-end infrastructure, right? So it's, if you're going to have like a message queue or something like that, connecting via WebSocket makes a heck of a lot of sense, right? So you can just it's like a TCP/IP connection, more of a direct connection like that. It's not TCP/IP, but it's like that, right? And so it's using WebSockets. I'm actually using binary transfer between, it's the data transfer back and forth. I'm using message pack to basically package up everything into a binary format, and then to decompose it on the other side back into kind of native JavaScript object land. And so what that allows me to do is I can transfer binary things like images, right? Or audio or what have you, that wants to be binary, right? And so what message does is it sort of handles all of that packaging back and forth. But it also, everyone's opinionated. I'm opinionated too. And so I have an opinion on how to, I want to phrase this, how to do message queue operations, right? And because I don't want to have to rewrite the wheel over and over and over again, right? So that's has its own set of opinions and flavor for how to do stuff and everything. So this is kind of an abstraction layer over NATs is really what it is to some degree, right? Because I'm not dependent, none of my services are dependent on NATs or know anything about NATs, right? They all know about this message module, right? And the message module, how do I approach this? Because this is kind of an important piece. Uh, so it's kind of like, to some degree, it's sort of like you have a call response kind of mechanism. You can call it that. It's a way of doing, like I said, message queue operations in kind of an abstract way. So there's certain things that I want to do over and over and over again. So let's look at the types. Maybe the type will lend us how to do that. So if I can make if this is going to make sense. Listener. All right. So we have a connection listener. So we have listeners. It's all based on listeners as far as how this works. I really wish I had thought more about how to approach this. But this is the fun of it. I'm just not gonna. I don't want to spend forever doing this. I'm not great at documentation. I'm doing the best I can. Give me a break. Uh, so how do I want to approach this? So you're just seeing a bunch of code that you don't know how it works. Message map, message connection instance. Message connection isn't going to give us what we want. Status connection map is really kind of the key of it. Request response. And you're going to need to see a concrete implementation of it that makes sense, because it's too complex for me to type it out correctly. So I had to do unknowns on it. How do I want to do this? So let's just look at it. I really wish this was a little bit simpler, but we're gonna just look at this type. I think this type, as horrible as it looks, I understand you're like, what the hell? There's a method to this madness. And the method is these two calls right here, request and request many. So you have an operation, right? So let's look at request. That's the simplest one. So we're just going to focus on this. Just ignore everything else except for this little bit right here. So request, right? So you have a subject, right? You have a message queue, so you have some sort of subject or topic or whatever you want to call it, right? And so you want to send a request on this, right? It's, like I said, this is kind of a call response paradigm, right? There you can do message queues lots of different ways. This is the one I've adopted, right? And so you have listeners that are listening on subjects that listen to requests and then respond, right? So in a sense, it's very much like REST or something like that, right? You have a request and you have a response, right? And so we have a request that we specify through something called a connection map, right? So a connection map will become important. And then you have headers, right? So if you have special metadata that might want to be known about, like, an API key or something like that, or a particular URL you might want to route to, if you want to route to something particular that's out of the ordinary or something like that, right? All the services typically want some sort of little metadata sort of thing, right? And then just have options here, which is essentially just timeout for right now, right? Which is, yeah. One of the things I discovered is you don't want to have a thing in a distributed system. Time becomes very important, and you want to deal with failures, in particular things like timeouts, in a coherent way. For one thing, you want it to just not block forever, right? Like on timeouts, right? Where it can just block forever, right? If you never get a response back, especially on something like a message queue, right? Where you're sending messages back and forth, right? So it gets a little like you can just have something that kind of floats out there forever, right? Never a response. So having a timeout is very important. So that's why we have this timeout option. Now, the other thing I want to call your attention to here is this request many. So like I said, there's kind of two ways of doing think of it very, very high level, like a function call, right? You have your arguments and you have your return. And that's a very simple way of thinking conceptualizing a function. You can also have a thing, sometimes it's called like a generator or something like that, where you might have multiple returns. It might return multiple times, multiple things, right? It's like yes, I got this data, and then I'm just going to stream out forever, right? Like for instance, like there's you can do like a generator based on random numbers or something like that. Just give me noise forever, right? Just static, right? Or some mathematical operation or something like that, right? You know, you can just give me the next one, right? Like the chaos. What's the chaos function called? Mandelbrot set and stuff like that, right? Just give me the next one. Just iterate over and over and over again, right? So there's operations where there just is no end, right? It's just like I'm just going to stop calling it to some degree. Um, and that's what this request many is, right? So this is basically like for text generation, right? Where you're just getting the next token, and the next token, and the next token, and so forth. Like that's obviously I say token, but it's you're getting back little text fragments, right? Because that's reconverted back into text. But I'll just probably use tokens. So you're getting many of those, and at some point it stops, right? There is an end to it, right? So there is a done state, right? When you get a response. But you can have multiple responses is the point, and then at some point it ends, right? And so this is my way of modeling the fact that you can have multiple returns. And this is it. I found it convenient, let's say, to break this into two separate kind of categories of operation or function or what do you want to call it, where you can either just have one that does a request and it's just kind of one and done sort of thing. That's just simple, right? Some things it's just you just want the simple, give me the one thing, and then sometimes you want multiple, right? And so this is just the way of doing it. And for the simpler functions, if I do request many, it's just going to return one thing, right? So it falls back cleanly um, in both cases, right? So that's how that works roughly. So anyway, so I talked about that, so I could talk about the message generation. Let's see, let's go back to services. All right, so now we're back to services. And so now you know a little bit more about how the message queue stuff works, right? So this is the message queue service is really just NATS, the NATS, kind of the raw NATS server at the end of the day, right? But everybody has to connect to it, and so there's just a well-known name for it called MQ-service that everyone can connect to. So let's look at, I guess let's look at text generation. It's probably going to be the most interesting one to look at. So we'll look at the text generation service here. And then that might be close to the end. I'm kind of running out of coffee. Transfer over to water. So, I'm nearing my end. Throat's getting a little sore here. But anyway, we'll push on for just a little while here. So we have the text generation service. And I tried to be, I'm trying to format like all the readmes and all the things kind of in a sane way, so they're all kind of interlinked and all that sort of stuff. So I'm trying to be a good Samaritan and document this as well as I can, even though I'm not very good at documentation, as a developer, right? So this is the Docker file. It's a very simple Docker file just based on Alpine that basically just does a typical TypeScript. You're wanting to start a service sort of thing. So this is sort of very basic, bare bones sort of thing. I guess maybe the one thing to note is I'm using PNPM these days. I'm not particularly in love with it, but it seems to be a little better than raw npm. Maybe at some point I'll use yarn, who knows, right? Bun, I kind of like bun to some degree. They all have their good points and their flaws, but I'm using npm for right now. So let's look into the source code, because this is kind of like how all of the services are organized. And so if you look at one, you're looking at all of them to some degree. So typically I start off with an index.tx because, I just want a clean entry point that says, okay, this is how this enter here, right? And then I typically do a main off of that. Maybe that's not a great idea. It's probably just an abstraction that doesn't need to exist. But anyway, I've done it. That's what I've done all over the place. And it does kind of serve a purpose to some degree. Um, but you could argue that it's just noise. So main does this get connection, right? And remember, we have this concept of connections to the message queue, right? Or maybe you don't remember. I'm telling you that we have this thing now, and so we can initialize the connection. So this is the connection to NATs, right? So this is kind of the heart of the thing, right? So a NIT connection, essentially, we just want to have one connection. So that's why I have this, get connection that just, just this very simple pattern here to make sure I just get it once, right? So it's just brute simple. Kind of a caching strategy. So the init connection does this get env, right? Which is, this is another pattern that I use, right? Where I just have an env and then I say, hey, these are all the things that this thing knows about, right? As far as what's in the .env file, right? And for this one, it knows how to do LLM stuff, and it also knows how to do embedding stuff, right? So this is one where it's like maybe text gen service turned out not to be the greatest name on that. It's always hard naming things in computer science, right? It's one of the three hard things. Famous joke. Um, so or two hard things. Famous joke, rather. Okay, so we're getting the URL to NATs, right? So this is essentially where we're going to do the NAT server, right? And then we have the URL. The URL gets passed into the server thing, right? So that's how we connected that, right? Options, we have logging options. I'm just logging to console log. At some point, I don't really need, my plans, if we want to call them plans, that's kind of a grand idea for what these ideas in my head, are to do like an observability sort of infrastructure sort of interface, right? Because that's the thing I want to do over and over and over again as well, right? So we'll see what that turns into. For right now, it's just simple logging, right, inside the Docker container. Who knows what that'll turn into later? That will almost certainly turn into something more. We have the token. Remember, I talked about we're doing token authentication to NATs. The reason I need to do tokens and have kind of a secure environment for all this, and rely on Cloudflare to give me both HTTPS, right, SSL sort of stuff, right, and that kind of layer of security, right, of encryption and so forth. So I'm relying on Cloudflare to give me all that, but I also need kind of an authentication mechanism. And so we're using the authenticate the tokens to authenticate. So that's how clients kind of get into the world of all the services and so forth. This NATS auth token is everything, right? So there's no real concept in my little system world of users and groups and these sorts of things. Maybe that might come in later. Maybe. I don't think so. It doesn't seem to be a thing that I need at this point, and I don't know if I'll ever need. It might be that the authentication token, like each user gets their own world in some sense, right? Of like all the services connected to this thing or something like that. Who knows? I want to keep it as simple as possible. So for right now, no concept of users or anything like that. You have the NAS authentication token, you're in, right? So that's how that works and how the security and so forth works. And that works great for me, right? In what I'm trying to do, right? I'm trying to create a little system for myself, right? That, where it handles my home infrastructure, right? So there's not really a concept of multiple users because there's just me, right? So that's why I can get away with keeping it very simple, and that does simple. I'm obviously an old school corporate software developer, and so users and permissions and stuff like that. That's a huge thing, right? That a headache I just get to ignore completely, and it's beautiful. Um, so let's look at one of these listeners. So here's the text gener. So the listeners, so you'll know, I didn't even talk about that. So subscribers, right? And then we have these subjects, right, or topics, or whatever you want to call that. And the pattern that I use is we have something dot something, right? And this is kind of a NATS built-in pattern. It's pretty generic across most SHQ systems, where you have kind of like this the path in NATS they call it. I think they call it like the topic and the subpath or something like that. I can't remember what they call it exactly, but the big part and the little part, maybe, right? Where text gen, so it'll be text gen and text gen dot whatever, like sub operation, like operation sub operation, or like service operation, however you want to call that. And then we have the listener that's listening to on that, that's subscribing to that, right? I'm probably over explaining that to some degree, but I guess it's better to over explain than not explain enough. So remember we talked about the fact that we can return multiple things or just return one thing and so forth. So this is essentially like your function, right? Think of it like that. Like, hey, here's your function. Here's your function call, right? And so the body, right, gives you the arguments for the action you're trying to do. In this case, we're just looking at whether this is for text generation, whether you're streaming or non-streaming. Um, Lots of times, like, or not lots, that's just kind of how it was done, right? Maybe it's a historical thing, right? Where there's usually a streaming mode and a non-streaming mode, right? For me, for my purposes, streaming is kind of the only one that's kind of interesting. So I haven't even implemented a non-streaming one because it's just not interesting to do that. Obviously, that's relatively trivial to turn a streaming thing into a non-streaming thing because you just got to capture it and kind of put it together and return the result. But that just hasn't been worth it so far, so I just haven't done it. So at some point I'll do it, but for now I'll just throw a new error. And I guess it's one nice thing to say that I have done the error handling. I have put a lot of thought and time and effort into error handling and so forth. So you just throw an error here at this point, and the actual error does get, including stack traces and all that sort of stuff, does get elevated to the client, right? So the client can see the error that's happening on the back end, and so I can kind of know, hey, what the problem is. So that's one thing I did spend some time on, is the error handling. So here's the real meat of the thing. How far into the details of this do we want to go? Not very far. So it's basically just a bunch of code for doing text generation stuff, right? And a lot of times it's just I'm using pipes and stuff like that to, because I'm calling here's a fun thing, right? Olama, right, I recently discovered that I didn't have to do this, but I didn't know that at the time because Olama didn't have it documented. Urgh. Olama only documented their, it's called like API chat. Do I have a, no, it's not here. It's like the .env file. But they have one endpoint where they decided, oh, hey, we're just going to send new line delimited JSON, which is what this is, and we're going to ship that back, via our SSE stream, right? And we're not even going to do proper SSE. We're just going to kind of do a fake SSE. And then there's like everyone else in the world uses the Open AI standard and does kind of proper SSE returns, which SSE is just sort of a kind of a very old school mechanism for doing streaming data over HTTP. I don't know, look it up. It's real pain in the ass, to be perfectly frank. So I had to create my own parser for it, right? Which with all the stops and stuff like that, because stopping is important. Like there's certain tokens you might just want to stop on, and then like one of the things that I've I'm going to pat myself on the back here, is I want to be, I've learned how to be very efficient, right, with dealing with these sort of services that do do things like inference and streaming and stuff like that. And so I'm very cognizant and careful about doing things like abort signals and that sort of thing, and making sure that I'm stopping and closing things appropriately when generation wants to stop, right? Because that's one of the things that happens, right, for users, right? It's like, oh, hey, the LLM's spitting out this, 2-page diatribe of whatever. No, I just stop it, right? And just to say, stop it, and on the client, and then have that abort go through my entire system, right, to eventually end up aborting the fetch, right, that is being called on like Open Router or something like, or Olama or whatever, right? At the end of the day, it's usually REST calls on the back end. Not always, but generally. Um, and so just having to do that and clean that up, clean it up nicely, right? Aborting is one of the nicer things that my system does, right? Is I don't even know how to properly tout the importance of that, if because it's one of those things, if you don't know that it's important, like how can I convey that to you? Because it's one of those things where you have to stub your toe really hard, and then you'll discover, oh, hey, that's really important. So that's one of the things that's really important that I do, right? And so I stop appropriately. I can abort my processing on a dime, right? And then stop words are essentially like when the LLM is talking, and there's certain phrases that you want to stop on. A lot of times this is because the LLM is, especially the early LLMs, were not real good on knowing when to stop, and what their stop tokens were and that sort of thing, and so would not stop generation. Um, anyway, that's a whole world and mess. So there, I do handle stop tokens correctly on my side as well, including things like partial stop tokens and so forth. Anyway, I'm not going to get into that. So anyway, I just want to say it's very advanced what I'm doing here as far as an SSE parser, right? So that's the thing, right? So this is just parsing the actual raw SSE data parts that are coming across, right? And looking at stop tokens and so forth. Anyway, I'm going way far into the dirt here that you don't care about. So anyway, so that's at the end of the day, I'm just routing, right, to some other API service, and then I'm packaging it back up in my formats. So let's look at my format. So TextGen common. So this is another high-level concept of, typically you'll see the service and then it has a common right next to it, like tunnel common, tunnel service, right? Data common, data service, right? So there's usually a pairing for this. So in old school Java, there was this thing called an IDL, which was called Interface Definition Language. And what that was a mechanism for kind of just, you know, what it says, right? Is essentially for describing an interface so that someone else could consume it, right? So you kind of think of it as a bit like, right? These days we have like the JavaScript equivalent of that is like open API, right? In that sort of paradigm, right? Where it's basically you just kind of expose your REST API via this structured format, right? And then everywhere else can just consume that structured format, and that's how your REST service works. So I've created a similar paradigm for myself on for all my services. You just consume this common thing, and then you know how it works, right? And this is where the connection maps come into place that I didn't really properly explain. So maybe we'll explain this a little bit better. So what this is it's a little bit of a TypeScript um, paradigm, I guess, to some degree, right? Of this mapping, this type map idea and concept. And what it is essentially you can have things where it's like, oh, I have this string, right? This very specific string, right? that maps to this very specific. Whoops, did I just do something there? I don't think I did. Anyway, it just looked a little bit weird. So it's essentially a way for getting types across. I don't want to explain how types work. If you know, you know. If you don't, you know. Um, but it's a way for me to expose, hey, here's what the operations are, here's what the request looks like, and here's what the response looks like, right? So here's the request, right? There's your request, the set of options, right? Which is, in this case, I have a lot of options, like what the provider is, what the prompt style is, what the template type is, what you want to stop and what you want to stop after. Uh, so I'm not going to go into what all those are. Stop after is kind of my own little personal concept because I need to, anyway, I don't want to get into it. I almost got into it. And then the body, which is what I'm calling the open router text gen request, because that's kind of it's basically an open AI's request model. I'm using Open Router a lot more than I'm using OpenAI directly. And Open Router adopted the OpenAI standard with some small tweaks. Everyone does a little small tweak. And their little small tweak is they accept either messages or prompt, right? If you know, you know, but just roughly speaking, there's two different ways of typically calling a large language model. One is where we're going to package up the messages, like the message traffic in a chat sort of thing, or the other is kind of more, sometimes it's called like the instruction mechanism, or the instruct generation, however you want to call it, where essentially you're just providing a prompt and then it just spits out whatever, right? So it's just kind of at the end of the day, it's all packaged into a prompt, right? It's just the messages are just kind of a nice format because everyone has their own templating mechanism for packaging the messages into a kind of a coherent fashion that the LLM can understand, right? So it's just all these little tokens that and everyone did a little bit different. Everyone used a little bit different pattern, a little bit different. Begin token, end token, begin of sentence, end of sentence. Everyone did it a little different, right? Everyone is continuing to do a little bit different. Do system messages belong, inside of that, all that sort of junk. It's just it's still a little bit of a mess. But anyway, but broadly, there's two different ways of doing it, right? At the end of the day, it's all a prompt, right? That we're sending the LLM, and then it's fitting out the one token at a time, but then there's specialized tokens in there that says begin and start and all that sort of stuff. Anyway, that's more detail than anybody ever wants to know. But OpenAI does it this way, and so I kind of like that, and so I've adopted their standard as kind of my standard for doing that. And so that's what I accept. And then if I'm talking to OpenAI, I can just pass that directly, right? If I'm talking to Olama, maybe I have to do things a little different, right? So that's just what it is. And by the way, like I said, the Olama I discovered later actually supports a proper, I'll kind of say proper, quotation marks, OpenAI, I don't know, protocol. So that they actually spit back correct SSE responses and so forth, right? So I didn't have to go through all that. But you live and you learn. And then I have a response. So my response is very simplified. This is probably the point where I've simplified it compared to like most people that speak like the true OpenAI protocol, right? Is that I just have the delta, the actual full text. I don't, maybe that's good or bad. It's probably a little bit. It makes my life a little bit easier in some cases, but it's not particularly efficient to spit back the full text every time. But I don't really care that much. And then whether or not we're done, right? Because that's the key thing on text generation is like at some point it's going to stop, and it can tell you that it stops, and so we have to say that we're done. And then, like I said, the headers, whether if the client wants to specify, hey, use this URL, use this auth token, and so forth. So there are some headers. Otherwise, we'll just use whatever the default is. And then this is my embedding request. So this is like if you're not aware, this is how we do vector database sort of stuff We turn, strings of text into numbers. One of the things I will point out here, right, is float 32 array, right? So we're doing an actual binary. My in my system, I do binary stuff, right? And so a lot of REST APIs, right, they can't do binary, right? That's one of the major limitations of REST is that it all has to, it's all JSON, right? And so it can't, I say it's all JSON. You can actually return wherever you want to return. 99% of the world cited JSON's what we're going to return. Uh, you don't have to. Anyway, I'm getting into another little tangent. So for me though, I've decided that I can just use the straight binary stuff because I'm using message pack at the end of the day, and I'm just translating it back and forth, right, between as I push it over the wire, right, and the message NATs, right, can do binary mode transfer over a WebSocket, right, so that's a thing you can do, right. It's not the default, but if you set up everything correctly, you can do binary transfers over WebSockets, right? And so it's a little bit more efficient and fast, and prevents me from having to do crazy stuff like base 64 encoding of all the data and stuff like that, right? I can just work with the raw binaries and be happy, right? So that's how that works. All right, what else do we want to talk about here? Text generation, anything else? I don't really want to talk about any of that. Anything else I want to go over real quick? How long have we been doing this? Hour and 21 minutes. So this is a long video. Do I want to cut it off here? The only other thing I might want to talk about, it's kind of interesting, is the data service. I'll talk about it briefly, just to give you an idea that I'm doing crazy stuff. Um, so I really love object databases. Just as a developer, it's just an easier way of, I just have this JSON object that I want to do, and I have an entity, and I just want to create entities and be done with it, right? Like I want to create my own, you know, as I conceive of this object, right, and what the shape of it is, and I just write it up, like I write the type for it in TypeScript. I just want that to be the thing, and then I query for it, and then I get it, and I don't have to worry about anything else, right? I don't have to worry about relations. I don't have to worry about properly typing it inside of a relational database, doing the translations back and forth, and migrations and all that sort of junk, right? I don't want to have to worry about any of that. So I created my own object store for doing that sort of stuff. You'll see here I actually have an object store and a vector store. So I'm using, how am I going to phrase this? So I've also more recently, I've been using the object store thing for a while, like a month, and then the vector store is more recent, like, a few days, weeks maybe. So this is all still kind of new and fresh, and I'm just playing, experimenting here. But I have a concept of how do I really want to go into all this? Let's just go into the types. That'll probably just be the most interesting thing, the most approachable thing I can do. So here we go. Here's the connection now. Remember, we're everything's in operation, and then we have request, right? We have response and headers, right? So data put, right? So I have this idea of an object store, right? Which is basically just a namespace. Optionally, you don't have to put a namespace in the store name, right? So it's essentially where you're going to store the data, right? Or you can kind of think of it as what the type of the data is, right? If you want to think of it that way. Whoops, I went the wrong place. So that's what an object store is. So that's just, it's just a simple type, but allows me to kind of, it's a nice abstraction, I guess I'll just put it that way. So we can put a value, right, which is a key and a value, right? Optional key, right, and value. Because all values typically have an ID string. And I have a very specific ID that contains the name of the type, the type name rather, right? Which is the object store type, right? So I have the store name, right? So I don't necessarily need the object store or the key. I can just throw in the value and I know where to shove it, right? Um, but I can provide it if I want to, right? The key is basically just the ID, right? Or if I can provide it, with the type and the ID and then data. Those are kind of the three things that you need to be able to kind of do an object database sort of thing. Um, but I encapsulate both the ID and the type inside the concept of the ID string itself, because it's a semantic ID, right? It's a very particular format that knows what it is, right? So I encapsulate both, right, inside the ID. So then I just have very simple operations: put, get many, right? Because we want to sometimes return more than one thing, right? It's just efficiency thing, right? Response, you know, T colon or undefined. It really should just be T colon. I mean, colon, I said, why am I doing that? Array, right? An array of types, array or undefined. I'm getting a little tired. I apologize. Um, anyway, so let's push forward though. So we can search. So I'm using James Path as my search mechanism for discovering data. Uh, this is clever or unclever, I don't know. But that's what I've adopted, and that's what I'm using. Now, a key critical thing, then I can remove, and here's my vector operations. I can create a collection. I can do a put and a delete. The important thing to note is I can do this point. Point is a number. I did numbers at the end of the day. I thought I was doing, here we go. Yeah, float 32 array. So I can search for, here we go. Yeah, here's what a point is. So I'm adopting the quadrant idea of what how to do a vector, how to do a vector database, right? So they have this idea of what they call a point, which is basically just three things, which is an ID, right, which is a number or string, a vector, which is the vector, right, typically, which is the array of numbers, right, which again, I do as a float 32 array. And then a payload, which is very interesting concept in Quadrant, actually, because you can query off the payload itself and kind of scope and filter it down uh, via the payload, right? Which is I haven't really explored that fully, but that's the important, neat thing that you can do with Quadrant, right? You can do it with whatever. Like at the end of the day, everyone's kind of the same in some degree, but I enjoy the Quadrant payload concept, and being able to query off of it in particular. So here's what I think of as a payload, right? Actually, so that should not be, no, that should probably be payload, because I do have a payload type now, but whatever, it doesn't really matter. I'm still kind of exploring and playing with these ideas. So, and here's what I think a payload should have. These are all the things I might want to query off of at some point in the vector database. What the content ID is. I have this idea of a room. We'll get into that. I have ideas on how to organize chat conversations that are novel within the context of agents and that sort of thing. So room ID, assistant ID, user ID, start and end point, blah, 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 right? These are all the things you might want to query off of or know about if you're doing, text vector sort of stuff. I haven't even gotten into like reverse image search and all that sort of stuff with binary data. So that'll be a fun thing to get into at some point. But anyway, we'll do that another day. The thing I just want to say is that I'm doing, like I said, my own kind of object database. It handles both binary and more textual information. I actually store the binary data separate from the JSON data. I actually, at the end of the day, I'm storing everything in memory, which is crazy, right? But the way I'm doing that is I'm essentially I have the how do I phrase this? Kind of the JSON parts. Let's say it's because it's let's say it's an image or something like that. I have some binary data or it's an audio file or something like that, right? I don't want to store that in memory, right? Because that's huge, right? So I want to store that sort of stuff on disk, right? And then what's it called? Swizzling. So I essentially just have a token, let's call it, that lives in memory, right? And then if I have to, and then I swizzle and unswizzle back and forth as I can do my James Path search all in memory. So I just have one big huge document, right? That I do all that is my entire universe of objects, right? Which is going to be fine as long as it stays within memory, right? Which hopefully it will. We'll find out. This is the part where it's just a lot of fun, right? To write your own database. Holy mackerel! What a madman would do such a thing. Don't recommend doing this. It's just almost pure fun for me. But anyway, so that's what I'm doing. But I don't want to store all the binary data in memory, so I'm swizzling back and forth between, and then I have like a content ID sort of system for storing stuff on disk and so forth. I don't. It's probably worth its own little video on how to do the data stuff. But I just want to maybe kind of express, that I'm doing some kind of just fun stuff, right? For that this is a way for me to experiment and play with these ideas of like, oh hey, how would I want to do? I want to have and with good motivation, right? So my motivation is that often I have in some little project I'm creating, right? I want to save data. I want to do stuff, right? Uh, well, I just want to have one standard way of doing that, right? Which is this way, right? Which is this object store way, right? And so, I've been doing this over and over and over again. This is not my first object database I've written, right? This is just kind of the most recent incarnation of that, right? Yeah, maybe this time I'll get it right. Who knows? But this is, my service. This is my object database service, right? And so this is, and then it plugs into the rest of the universe of services, right? Text generation and I haven't even gotten into the daemons and stuff like that. We'll get into that some other time. But so we'll just call this kind of the high level overview of the MJT services, and then maybe I'll dive deeper into the other services as they become interesting, right? Um, but yeah, we'll just call it here, I think, with data. Uh, so I don't know. Hopefully somebody got something out of this. If nothing else, maybe like don't ever like holy mackerel. What why would you do this? Maybe it's just shock. I don't know. Entertainment. Like what kind of madman would actually want to do all this sort of stuff? Um, but anyway, I just wanted to kind of describe it, show you whoever happens to be listening to this, what I've been up to, what I'm doing, kind of what the current state of it is as of April 1st, 2025. April Fools. Happy April Fool's Day. I promise you this is not an April Fool's joke. Although maybe it kind of looks like it. I don't know. So anyway, so this is what I've been up to. This is kind of where this uh, thing is at currently. Um, and it's just at that point, and as I described in the previous video, where it's starting to become useful, right? Where it's like, oh, hey, I can connect this via the Brave browser, via the Bring Your Own Model into this world I've created, right? And now I can start using all of these services, right? Now I can start using the vector database and the daemons and the agents and stuff like that, right? To actually do real work for me as I'm, exploring the web, right? So we'll see what comes of that, and obviously in VS Code via the Connect thing and all that sort of stuff. Um, but And then, obviously the Home Assistant project. So the Home Assistant project is still alive. I haven't even shown that off yet. Maybe I'll probably do another video just on the Home Assistant project, which is effectively the user interface to all of these services, right? And it's for, basically interacting with agents, really, roughly, broadly, um, and kind of how I want to do that in my own interface for doing that. And it's really a way for me to kind of play with ideas and explore it and or customize, right? Like I have opinions on how this wants to work, right? And I want to test my opinions out. So it's a way for doing that. Uh, but anyway, I just hopefully you get out of this that I'm having fun here and I'm creating stuff. It's all open source. I'm just in a position in life where that's I can just do that, right? Where I can just program for hours and days, and as I'm a software developer at the end of the day, right? I've been doing it my whole life. Uh, it used to be that you can make a good living doing that. I don't know with AI and all that sort of stuff. We'll see if that continues. I think it will, but I have opinions on that too. Maybe I'll express those at some point. Uh, but I this is just the way that I view the world, right? And this is the way that I kind of interact with it, right? Is by creating software that allows me to explore these concepts and these ideas and uh, kind of create something out of it, right? It's just I get in my flow state and I get into it's just my joy, right? If I was a painter or something, I have done that in the past too, right? I guess that's maybe a bad idea or bad uh, what would you call that? Like alternate conception of myself that I want to use to explain a point, right? Because if I was a car mechanic, maybe I'd be out there tinkering with my car in the garage or something like that, right? Um, so this is me tinkering with, you know, uh, just software, right? Just uh, these principles, these and it's like an exciting time with AI and so forth, right? And so that excites me, and I kind of want to pursue it and just see where it leads to some degree, right? Uh, and I guess maybe it's just the end of the day, I just like creating stuff. Anyway, I'm just talking to myself at this point. Anyway, I apologize for that, but I really appreciate your time. If you did happen to listen to this, hopefully you listened to it on like 2 or 3x speed or something like that, and it wasn't too boring, and you got something out of it. I'll continue making some progress videos on this. It feels like I've been doing this for several months now. It feels like this is going to be a thing that I'm going to do long term. Um, no promises. The code's out there, and the code will be out there forever. But it feels like I'm going to be continuing this for the foreseeable. We'll see what this turns into. Maybe it'll be fun to look back on this for like years or decades, maybe who knows, from now, and see what you know if we're still doing this, or if that was just a dead end on some in some sense. But so far it's feeling really good. It feels like I've kind of crystallized, like I've had these ideas for a long time. I've had a lot of I've just had decades of experience at this point, right? So I kind of know what works and what doesn't work, but I have a sense of taste, I guess I would say, right? What's going to work, likely going to work, and what likely isn't going to work, and that sort of thing. And so that's also kind of what I'm expressing and exercising is my my taste preferences on how to do all this sort of stuff. But anyway, I'm just rambling at this point, and we'll uh, we'll catch you later. Have a good day. Have fun. Most of all, just have fun out there. Take the good parts of this that you see, and just leave all the rest. And we'll catch you later.